So yesterday we talked about finding inverses graphically and went over a lot of definitional terms for what is a relation, what is a function, what is the inverse, is it one-to-one, etc. Today we're going to start talking about how to find inverses algebraically. Okay, so it's going to be a fairly straightforward process, and it's really the reason why we started this unit off with a review on how to solve certain types of equations, because essentially that's what we're going to be doing here. Okay, all of your directions on every problem that you're going to get that say to find the inverse algebraically are going to be something along the lines of, given the function f of x, find the inverse function, and it uses this notation. Okay, this notation, it's very important that you understand that this -1 is not, I repeat, not an exponent. This is just the notation for the inverse. Okay, this is read the inverse of f of x. Okay, so this is called the inverse of f of x. Okay, don't say f to the -1. Okay, do not do that. It is f inverse of x. Okay, so algebraically, what's the process look like? Pretty simple and straightforward. First off, we're going to remember that f of x really represents the output. Okay, the output can also be represented with the variable y. So we're going to go ahead and replace f of x with y. Then we're going to swap all of the x's and y's, meaning if it was a y, now it's x. If it was an x, now it's a y. Then we're going to go and algebraically solve the equation for y. And then once we've done that, we're going to go back and replace the y with f inverse of x, indicating that it is the inverse of that particular function. Okay, now an important note to make. If we're finding the inverse algebraically, we're only finding the inverses of a function. If something is not a function, we can't really find the inverse function. Okay. That being said, anytime you're given a problem, if it starts with f of x or g of x or h of x or k of x or anything that uses that function notation, we are just assuming that it is a function and we can find its inverse algebraically. So we're going to run through about 5 examples. Okay. The first one is the most basic. Okay, it says find the inverse of f of x equals 5x plus 2. Okay, this represents a linear function, and its inverse is also going to be a linear function. Okay, so step 1 says that I need to go through and replace the f of x with y. So this is now y equals 5x plus 2. Then it says I need to go and switch my x's and my y's. So second step, I'm going to say, well, now it's x equals 5y plus 2. Okay, so the third step says that you're going to go and algebraically solve this. All right, but what am I solving it for? Y. So I'm trying to get this y all by itself. Okay, in order to get the y by itself, first I'm going to subtract the 2. So if I started with x equals 5y plus 2, I'm going to subtract the 2. So x minus 2 equals 5y. Then I'm going to divide everything by 5. So this becomes 1/5 x minus 2/5, because that's what happens when I divide x by 5 and -2 by 5. And that will equal y. Okay? So our inverse function, last step is go through and replace that y with f inverse of x. So we're going to say f inverse of x is 1/5 x minus 2/5. Okay. Could you also have written that as x minus 2 all over 5? Sure. They mean the exact same thing. I just think this one's a little bit easier because, especially since we're talking about a linear function, we can see that this one has a slope of 5 and this one has a slope of 1/5. Kind of makes sense. Okay. So It's really just a lot of very basic solving. Okay, we're just going through and running through the steps, replacing f of x with y, swapping x and y, solve the equation for y, and then replace y with your inverse notation. So for the second example, it says find the inverse of f of x equals x cubed minus 1/5. So if we start by taking a look at that one, then we're going to see that we're going to need to replace the f of x with y. So I'm going to say y equals x cubed minus 1/5. I'm going to swap my x and my y value. So this is now x equals y cubed minus 1/5 because everything else stays the same. And now I'm just going to go and solve for my y value. Okay, so I'm going to add 1/5 to each side if I'm solving it. So I get x plus 1/5 equals y cubed. And then to get rid of the y cubed, I'm going to need to go and take the cube root of each side. Okay, so I'm going to take the cube root of each side. I would get rid of a square by taking the square root. I get rid of a cube by taking a cube root. It just makes sense. Okay, so that's going to leave me with simply the cube root of x plus 1/5. I can't really do anything algebraically to simplify that at the moment, and that's going to equal just y because a cube root and a cube are inverse operations. And then at the very end, I'm just going to go and say that f inverse of x will be equal to the cube root of x plus 1/5. Okay. Now, hopefully you notice here that we started off and the original function was a cubic function. Okay. But its inverse is a cube root function. Interesting. Kind of like they're opposites of each other. Amazing. All right, let's take a look at another one. Okay, this one has all sorts of fractions, but it's cool because fractions are our friend. So we're going to find the inverse of f of x equals 1/2 x minus 3/4. So first thing I got to go through and do, replace f of x with y. So y equals 1/2 x minus 3/4. Second thing I'm going to go through and do is I'm going to swap my x and my y. So now it's x equals 1/2 y minus 3/4. And then I'm going to go and actually solve it. Okay, so I'm trying to solve for this y. So I'm going to start by adding 3/4. So x plus 3/4 equals 1/2 y. Hopefully, we all remember that in order to get rid of a fraction that is a coefficient, you just multiply it by its reciprocal. Okay, so I can go and just multiply everything on both sides by 2 because 1/2 and 2 will multiply to be just 1. Okay, so now that I know that, I have 2 times x is 2x. 2 times 3/4 is really 6/4, but 6/4 can be simplified. Okay, it can be simplified into 3/2. Okay, so that's where I'm getting the 3/2 from. 2 times 3 is 6. 6 over 4 is the same thing as 3 over 2, right? And that's going to equal y. The last step is just to do my inverse notation. So I would say that f inverse of x would be 2x plus 3/2. And again, just kind of doing a does it make sense, common sense kind of check. This was a linear function, okay, with a coefficient of 1/2. This is a linear function with a leading coefficient of 2. 1/2 and 2 are kind of like opposites. I guess they're probably inverses. Okay, now let's take a look at one that's got a square root on it. Okay, so it says find the inverse of f of x equals the square root of x plus 2 plus 1. So first let's go and write it with a y. So we're going to say y equals the square root of x plus 2 plus 1. And then I'm going to swap my x and my y value. So I'm going to say x equals the square root of y plus 2 plus 1. So now I'm going to go and try and solve for this y value, okay? And the y value is trapped inside the radical, and the radical has a constant that's been added to it. So before I can get rid of the radical, I got to get rid of the constant, okay? So I'm going to say x minus 1 equals the square root of y plus 2. Now I'm at a point where I can go and remove the square root by squaring both sides. But I'm going to go ahead and tell you all a secret. Okay, just leave this as x minus 1 quantity squared. I'm not going to require that you guys multiply that out or write it as x squared minus 2x plus 1. Just leave it this way, totally fine. Later on, when we start doing some graphing with inverses, it'll be easier to graph it this way than it would be if it was in standard form anyway. So win-win. All right, so the reason I squared both sides is because it's going to get rid of the square root. So I have a y plus 2 over here. And then if I was to go and subtract that 2, I would find the inverse. So f inverse of x is going to be x minus 1 squared minus 2. Okay, now I am going to go and put a little asterisk over here because there are some things that we're going to have to, or that we would need to consider when looking at this inverse function. But for the purposes of this class, we're going to say that this is an accepted correct solution, okay? We're not going to go through and get into a lot of domain restrictions with you guys, even degree versus odd degree functions or roots. So we're just going to stick with the plan and say that this we're going to go ahead and accept as the inverse, because for the most part, it is. There's just kind of teeny tiny little rules that we would have to go through and apply if we wanted it to be like 100%, but we'll be good with this for today. All right. So the last one we're going to take a look at is another square problem. So we're finding the inverse of f of x equals 4 times x minus 7 quantity squared. So going through our process, we're going to start by replacing f of x with y, and then we've got a 4 times x minus 7 quantity squared. I'm going to switch my x and my y. So x equals 4 times y minus 7 quantity squared. Okay. And now I'm going to start solving for y. Okay. But y is trapped inside of this parentheses, which exists because it's all been squared. But in front of that is this multiplied by 4. So I need to divide both sides by 4. So x over 4 will equal y minus 7 squared. Then I can go and I can take the square root of both sides. And that's going to mean I'm going to need to remember some of my rules from earlier in the year with taking the square root of a rational. Remember, that means we do the square root of the numerator over the square root of the denominator. Okay, those are inverse operations, so that'll be just y minus 7. So if we kind of keep the party rolling over here, we really just have the square root of x, and now it's over 2. Okay, but because we took the square root of an unknown value, we have to include a plus or minus. Okay, we took the square root of an unknown, we got to include a plus or minus. All right, and that'll equal y minus 7. So then adding 7 to each side, technically speaking, I would get that f inverse of x is plus or minus the square root of x over 2 plus 7. You could also express that as plus or minus 1/2 root x, because this means the same thing mathematically, plus 7. Okay, so either one of those would be acceptable as your solution. Okay, so to kind of recap, what are we doing? We're taking a look at a function that has been given to us. It is defined as a function. To find the inverse, we simply replace the f of x or g of x, h of x, k of x, whatever it is, replace the f of x with a y. you're going to switch places with all the x's and all of the y's, okay? Because we're inverting. The x's become your y's. Your inputs become your outputs, and your outputs become your inputs. Then we're going to solve the equation for y, and then simply rewrite it using the appropriate inverse function notation.